Okay, I'm starting the recording. So now we are ready. Welcome everybody. Thank you for joining us in this afternoon. I know it's very smoky afternoon and it's been difficult for all of us for this week. But we're actually happy because now we are finally bringing to a closure of one of the first pilot project for the for the project circle in data circles. So, a little bit about our circle. So, the mission for this circle is to give quote unquote real world experience to data science practitioners to develop a project that goes from conceptualization to execution. I think that's something that is missing sometimes. And it's always really good to learn why you do things. So that's why we decided to do the circle. If you want to take a look at the repositories of the projects that we were developing right now, you can check the GitHub repo. Also, the leadership of the people behind this list is Erin, Huda, Niwako, and Somya. All of us are the people behind this. And if you want to join us, you can fill out in the website for volunteering. All right. So, because we want to hear what people have to say, we will start by introducing the project. So the project was about analyzing data from traffic and collisions in Seattle. So basically, over the last 12 weeks, the participants worked really, really hard to do and develop projects that cover different data sets that we see here. The main source of data were the traffic collision data from the transportation department, but we also supplemented different things. And we also have some suggestions for data sources on GitHub as well. As you can see, we had, in preparation for the workshop, we had 3 workshops that were held virtually. And after the workshops were finished, we did a weekly stand-up for providing external deadlines and feedback on the project. So, like I said before, this wouldn't be successful without the aid of the volunteers and mentors, and I want to give a quick shout out to all of them. We really like to thank all of the people that participated and that made this event possible. Special shout out to our workshop lecturers, which were Niwako, Erin, Victoria, and Chad. Chad has really been a really good partner in this. So thank you, everybody. Also, we want to note the participants' effort, and we really want to applaud the effort. You did an amazing job. All of the teams that are mentioned here were awesome. We had 3 machine learning teams and 1 visualization team, and all of these people were involved, and we know you did an excellent job here. So we wanted to give a bit of a surprise to the effort they put on in the projects. So Data Circles has agreed to sponsor 1 book for the people who completed and presented today the project. So we will, if you want this book and you participated in completed project, Huda will share later one document where you have to basically send us your shipping address so that we can ship you the book in case you want it. But yes, just to make sure your effort does not go unrecognized and unnoticed. So with all that, I think it's time to start the project fair because we have very interesting presentations ahead, and the visualization team will be starting.
Okay. Monica, are you there?
Yes, I'm here.
Okay. Let me start sharing my screen. Okay, how's that?
Okay, looks good.
Great.
Yep.
Hi, everyone. I'm presenting on behalf of the data visualization team. My name is Monica, and my team members are Jenny, Rebecca, Nuako, and Jamie. We decided to focus on the visualization aspect of the collisions data project. Like everyone on the project, we started out with the data set provided from the Seattle Department of Transportation, which includes the years 2004 to 2020. In our analysis, we did not include the year 2020 because 2020 has been anomalous and it is also not complete. Along with this data set, we also use several other data sets. At the bottom of this page, you can see a Sankey chart where we mapped out which data sets we explored and which we ended up using for our final data set. The most important of these being the 2018 traffic counts, intersections, and 2010 census counts that we merged into our final data set we ended up using and importing into Tableau. So for our project, our final product was a Tableau story consisting of several dashboards. And yeah, Jamie, you can go to the next tab.
Hold on. Okay.
So our main question that we wanted to address in our analysis were which are the dangerous locations in Seattle? And the first thing we came across was how do we define a dangerous location? So we first had to come up with metrics to define dangerous locations, and those included traffic counts because we were large numbers of people. So we tended to focus on locations that included high volumes of traffic. This can be seen in this map by the pink lines. These pink lines represent traffic flow. The thicker and darker the line, the higher the flow. The other thing that you can see in this map are points. These points are locations which have had at least 20 collisions in the last 16 years. The size of the dot is representative of the number of collisions that have taken place at this location, and the color is relevant to severity score, which is a metric that we came up with in defining whether a location is dangerous. And this severity score can be calculated by summing the number of collisions for a location which are weighted by the severity of each collision. And the scale for this can be seen below, ranked 1 to 4. The other thing to note about this map is that the freeways are not represented. This is because the collisions data set did not include collisions that took place on freeways. So I-5, 520, and I-90. The rest of the dots are that took place on streets, city streets. The map is interactive, so if you scroll, Jenny, if you want to, yeah. So each location has a tooltip which shows the overall trend for the number of collisions that took place at this location, as well as what kind of collisions are taking place. So those are broken down by category. Because we were interested in, you can see that there are a lot of locations, a lot of collisions downtown, but because we were interested in analyzing locations with high traffic flow, we 5 particular problem areas which had a high number of severe collisions and also high traffic flow. And these are illustrated on the next tab. Five problem areas that we decided were noteworthy included 2 sections of Aurora, 2 sections of Rainier, and North Gateway. This dashboard is designed so that you can click on one of the Aurora, North Aurora, and Aurora Avenue North works. And set up so that you see each chart by filter. So each and in the middle you can send of collisions by collision type that took place in this location. Then on the left you have each intersection or each very specific location and the number of collisions that took place there. You can map with the dots and then Google Earth view. And at the bottom, you can also see the count of collisions by hour, weekday, month, the overall trend in this problem area, and also the percentage of collisions that were in inattentive driving. And the changes will go from each location. So later on, feel free to each of these problem areas by clicking the tabs at the top and the reset button to go back to the first one if you'd like.
It's freezing.
In general, we found that the number of collisions in Seattle has been overall going down. In these 5 problem areas included, there have been occasional blips of increasing collisions, particularly in 4 of these problem areas. And this summary page also includes other summary statistics that we found for these 5 problem areas, including October being the most October being the month with the most collisions, and certain time periods of the day where collisions are more common, as well as rear ending being a general most common issue in all of these problem areas. Again, feel free to look at this page in more detail after the presentation, and I'm going to pass it off to Jenny, who's going to talk about very specific locations within these problem areas that we have tailored recommendations for in improving traffic safety. So thank you.
Thanks, Monica. Okay, so on this tab, we're looking at the dangerous locations that we took an interest in. And like Monica had mentioned, we first focused on where are the biggest traffic flow. And then from there, we looked at the severity scores and the number of collisions to determine what areas we would like to focus on. So from that, we ended up with these general areas of Aurora Avenue, North Gateway, Rainier, as things to focus on. And then we dove a little bit deeper and looked at individual locations so that we could find areas that had specifically standout bigger problems happening than the general area that we then looked at and tried to determine, okay, what could we try to fix in this area, whether by a policy implementation or by a road improvement. So what we ended up looking at were Aurora Avenue from 140th to 145th, Aurora Avenue from 130th to 135th, North Gateway from 1st Avenue to Northgate Drive, North Gateway from Meridian Avenue to north to Corliss Avenue. Each of these locations are on the west and east of I-5. On the south side, we had Rainier Avenue at Orcas Street, which had a high level of left turn problems. Rainier Avenue, this whole section, Rainier Avenue from the intersection of Cloverdale all the way through Henderson, down through Henderson to Director. It's just a whole slew of different types of problems through this area because of what is there. So the as you all probably know, there's been a Vision Zero program since 2015, And the city has been focusing on a lot of the downtown areas and specifically on pedestrian type of improvements, starting with phase 1, which was a reduction in speed limits to help with the pedestrian issues. Because we focused on higher traffic areas, a lot of our areas involve more car situations, though many of them are still pedestrian. So the locations that I chose to focus on for this presentation and the recommendations involve those type of things that haven't really been as much covered by Vision Zero. So I'm going to go back to the exploring area, and we're here in Aurora Avenue North. And so I'm going to take a look here at 143rd to Roosevelt. And so you can see as I click on this bar that it filters everything specific to this location. So you can see in this area that left turn is a much bigger problem than the whole general area, which is this lollipop part of the chart. And then at the bottom, you can see that things are a little bit different for this location than the rest of the areas. Friday for the general area was the worst day, but for some reason, this area, Wednesdays, is the worst day for collisions. And October was in the general area, but for some reason, June is for this one. We also have an uptick in 2019, even though this general area has been trending down. So you can start to understand what's happening here by looking at the satellite map, and you can see that along this entire stretch, there's many entrances to parking lots of different residences and different small businesses along here on both sides of the street. And there's large swaths and this road here. So in this stretch of area on Aurora North, it is illegal to turn left going south, but it is legal going north. So in the middle, you can see we have what's affectionately known as a suicide lane. And really, you're only supposed to use this lane turning to the left, but not to the south. So this lane is somewhat problematic because really anybody can turn any which way they want to. And of course, there's more than one lane on each side. So that makes it, of course, more difficult to see. If we look at our recommendations tab, you can see a street view of this, and maybe a better view of what I'm saying is that there's a long stretch of suicide lane here and huge areas where, and this is a view facing south, by the way. So you're not allowed to turn left, but there's these huge areas where you could turn left because there's plenty of room to do so. And there's nothing really preventing anyone from doing that. So the recommendation we have for this area was to consider adding a raised center median with left turn pockets for the northbound traffic only. So it would be something along these lines over here in this inset image. So for each of these areas that we noted, you can see like we had some recommendations for 130th to 135th. For the Rainier Avenue, we have there's many recommendations and things that are actually happening right now because of Vision Zero in this area, but we do have some things that are a little different. And then in North Gateway also, we have some recommendations, so you can take a look at that if you'd like. And like Monica said, it's all here in our GitHub repository. All of our data is there, and all of our files, including our pictures and everything, are in our GitHub repository there, and you can take a look. So thank you everyone for your attention, and I want to thank my teammates because they were totally awesome, and for Erica and Aaron and Nawako and Huda and Somya for putting together the project. It was really great. We all learned a lot, and so we want to thank you for that. And with that, I'll just say if you guys have any questions, we are open to questions.
Thanks, Jenny. I also wanted to add that the link to our Tableau dashboard is also in our GitHub. So it's also in the README.
Perfect.
This is wonderful job. Thank you so much. I think those are this is so exciting to see how you can use data to do all of this detective work and actually get actionable things that you can do to improve something that impacts the quality of all of the Seattleites here. So this is really cool. Thank you so much. Any question from the public? Like, it could be something like, what is your impression of the data, or other recommendations that you might want to hear?
I have a question. This is Luna.
Hi, Luna.
So I'm thinking, by doing all those visualization, do you think you gain any insight about what contribute to a more deadly accident? Like, I think for some locations there lots of accident happened over the year, but some accident actually cause more serious injury. Some is more like just a property damage. Do you think there's some things like important factor contribute to a more deadly event?
Well, it certainly seems that, they become more serious injuries and more potential deadly event if it's a car hitting a pedestrian, or a cyclist. So those are more deadly. So, but we chose to focus on areas because of the traffic flow where there were just more accidents. So we were trying to focus on an area that was just where more people might encounter accidents instead of necessarily deadly. So we tried to kind of combine the two in order to focus on that. And what we ended up learning is that, like, the Vision Zero, it focuses very much on reducing pedestrian, which is of course super important, but we were kind of trying to figure out ways to attack where there was like huge traffic flow issues too.
Great, thanks.
There was another question in the public that said that if you were planning to where did it go? If you were planning to submit it to the Seattle police.
The intended audience of our visualization were Seattle policymakers. We definitely crafted the dashboard addressing policymakers as our audience, and that is something that we could consider.
Yeah, I would totally encourage you to do that, because this is an amazing job that needs to be shared and needs to be seen by the right people.
One of the things I was thinking about as we were going through this, though, and we started looking at the individual locations, like really drilled down, and we went into Google Maps and turned all around and went up and down the streets trying to figure out what the problem was. Like, I worked on North Gateway, and there was one section that I was like, I don't understand why it was having side swipes. And I think I figured out what it was, but I don't 100% know that what I figured out is what it was. So part of what I think I would like to do is actually go talk to a police officer that works in that area and say, okay, this is what I think, but is that what's really happening there? And I think that's an important part of really getting to know what's happening in these areas too.
Right, yeah, that's a great idea. Cool. Thank you, visualization team. You did an amazing job. If there is no other question, then maybe we can move on to our next team, which is Machine Learning Team 1.
Hello, everybody. Are you able to see my screen?
Yes, we can see it.
All right, great. So we are Machine Learning Team 1. My name is Fadli, and I'll be kicking off the presentation, but we also have Cindy and Isaac, who are here as well. Maureen, unfortunately, is moving right now, so she can't be with us, but she also contributed quite a bit to this project. So I just wanted to start out by saying thank you to all the organizers and to all the participants. It's been a good learning experience. and it's been a good chance to meet a few people, even though it's all been online. It's been a nice bit of community forming. And so I'm just going to go ahead and get started. So we primarily used a machine learning approach to exploring the data and finding different trends, different patterns in the data that were not immediately obvious. And the general approach was to build predictive models that could tell us which features had more significance in determining whether an accident was more fatal or pretty much trying to find what is associated with collisions in general in terms of street features. And so that took us down many different paths, and with 4 people in the group, we took many different approaches, different libraries and statistical approaches. And in this presentation, we'll primarily be sharing visualizations that we have because it's the easiest to communicate. So let's see, just here's a brief overview. Just like the other group, we're going to talk a little bit about Vision Zero and just the general motivation for a study like this. We're going to share basic insights that we have as takeaways, which you could think of as working hypotheses for future studies to get more confirmation on. We'll explore a little bit about what the collisions data looks like, share some visualizations of those insights, explain our approach to machine learning and how we try to, instead of just creating a good predictive model, we wanted to create an explainable interpretation of the data. So that takes us down a little bit different path. And then we'll just give you a summary of our takeaways once again, and a couple suggestions for the governance of this data, as well as future studies that could take our working hypotheses and explore them further. So Vision Zero 2030, as the other group mentioned, is a plan to significantly reduce injuries, particularly pedestrian injuries, related injuries and fatalities by 2030. And it's a fairly ambitious effort, and a lot of money is going behind it. And so there's a need for working with the available data to see what's effective and what is still causing fatalities or collisions in the city. And it's important just to take I'm sure we all here realize this, but it's worth noting, it's important to have a data focused approach, because there's a lot of ideas that people can bring to this, a lot of assumptions that end up funneling resources in a certain direction, but it's good to keep open mind as to what is the most effective use of those resources to actually reach these goals. And so the city has gone a long way to put resources behind this effort, and we're hoping that the projects here, including this one, will be a way to help guide future projects and make it a little bit easier for the next groups that focus on these issues. And so just a brief introduction to our insights and an overview. And like the other group mentioned, there's been a downward trend since 2005, which is great. Even before Vision Zero has started implementing policies. Distracted driving really accounts for more collisions than any other category, other than well, we'll see the slide in a second, but in general, distracted driving accounts for quite a bit of collisions, and we see a huge uptick after around 2012, and we believe that has to do with smartphones becoming widespread and widely available. So we would recommend policy focusing more in that realm rather than the typical idea of focusing on drunk driving, which accounts for quite a limited portion of the collisions, which might go against common notions about this issue. We saw reason to question whether traffic circles are helpful in reducing collisions. In fact, they might be counterproductive. when we compare them to normal intersections on non-arterial roads. We noticed some interesting seasonality in the collisions, particularly in winter time, in principal and minor arterial roads, and it was not entirely clear as what was causing that. So that's a reason for further study. The obvious idea would be that road conditions or weather, but it seemed to be something even different from that. So another takeaway is our city blocks have more collisions than intersections, which also might be a little counterintuitive. The other group mentioned there's a large amount of rear end collisions, and that could factor into this, as well as left turn. And also certain features we will highlight have a high association with fatalities, and we'll explain that with our machine learning models. So now I'll pass it off to Isaac.
Yeah, thanks, Philly. As you mentioned, yeah, we saw a huge spike in distracted driving around 2012, and it's obviously trending down since 2015. However, kind of the point we're making here is that while kind of speed limits are a big focus of the 2030 plan, we hope that policymakers don't lose sight of the fact of that distracted driving does account for quite a bit more of traffic injuries and fatalities yearly. Next slide, please. Yeah, we also wanted to point out that a lot more of the collisions in Seattle are occurring at a street level and not at intersections over twice as much. So again, while there's a big push for these pedestrian-focused signals in the city to reduce fatalities and injuries for pedestrians in collisions, again, we'd hope that policymakers don't lose sight of the fact that there's a lot more ground to cover outside of that work. Next slide, please. And again, we hope that we focus our resources on the types of streets where most of our collisions are actually happening, those being on non-arterial and principal roadways. And if we go to the next slide, we see that seasonality we were talking about. We actually introduced a few Bayesian statistical models to this data, and we also added, looked at weather conditions and surface conditions with this data, and the kind of the jury's out there on what's actually causing this spike on a whole. It's very possible too that this is a data management error, such a big spike from one year to the next, and this kind of looks like an error to me, but there's nothing to indicate whether that's one way or the other, but it's definitely something that we'd hope the police, which are generating this data, kind of look into more, and if it is correct, kind of adjust how they're citing traffic violations kind of around the early parts of the year in the winter accordingly. So that's kind of just an overview of our data. This is more about the data set that you'll hear all the groups talk about. I don't think we need to get into this too much. I think data visualization did a good job of introducing the data. But we brought in a lot of data from the streets and intersections data set because we wanted to look at road features that included features like speed limit, slope percentage, arterial transit class. Road width, which was promising, but on streets like Aurora, particularly on the Fremont Bridge, we kind of had trouble bringing that features like that in, because we know that while we know the road width, we don't know how much room like a typical driver has to work with in the lane. And the intersections data, while it was kind of interesting to play around with, it didn't have a whole lot of features that we were able to play around with. But we kind of persevered, and we'll get into those findings next, and I will pass it off to Cindy.
Hi, everybody. Thank you, Isaac. So now we're going to go into kind of explaining our approach to using machine learning on this data. So in the next slide, so this is kind of just our basic outline of our machine learning process. We first created kind of simple baseline models using light GBM and CatBoost to figure out which features of collisions lead to injuries and like the severity of it. Later on, after that, we decided to kind of narrow it down and look at collisions with pedestrians and cyclists versus when it's only just vehicles and no pedestrians or cyclists. And so the feature importances extracted can kind of help us see what Seattle should focus on in terms of like policy making. So we also then look into kind of the blocks and intersections, because like Isaac said, there's definitely a lot more collisions happening in blocks. There are also a lot more blocks and intersections. But the next slide. So with the collisions with no pedestrians and cyclists using the light GBM, we found that under the influence, so alcohol, drug influence is the #1 feature importance. And this makes sense. These features right now that you're looking at, alcohol influence, road conditions, speeding, weather, and lighting conditions, it's all features that are more related to driver, basically the drivers. So this makes sense for when there is no pedestrians, that the features related to drivers would be a lot more of an indication. So moving on to collisions with pedestrians and cyclists, you can see the crosswalk key immediately becomes the #1 top feature. And then next to inattention to driving, although inattention to driving, we're not really sure if it's talking about the driver not being having the correct amount of attention or the pedestrians and cyclists. But this definitely shows that pedestrian and cyclist collisions, the crosswalks is definitely a lot more important than the road conditions and all the other things. So afterwards, we decided to go into looking at the blocks, and this is kind of predicting the annual count of collisions for blocks. And as you can see, the traffic flow is definitely the most important, and this makes sense because when there's a lot of traffic, you're bound to have a lot more risk of a collision. And slope percentage is the second, speed limit, and then the transit class is basically kind of like arterial and all that. So moving on to the next one, we go into the slope percentage, because we know that it's after the traffic flow, it's the second most important feature. And we actually found that the top 10 blocks with the highest amount of collisions is only about like a grade of 1.4, while the bottom ones is higher at about 3.8. And this sort of does make sense because major roads like the interstate or freeway, they tend to not have that big of a slope. So after looking at the slope percentage, we went to looking at the traffic circles, because as Isaac and Fairley mentioned before, are they effective? And while the collisions occur less frequently at intersections with traffic circles as a whole, there's probably less traffic at a traffic circle, and there's a lot less traffic circles in general. So traffic circles appear to be ineffective at reducing collisions in residential areas. So then we move on to looking at the intersections on its own. And then again, you can see the signal type for intersection is actually the most important feature. And that you can see here that traffic circles has the least important. So we looked more into signal types since we know that that's the number one signal, number one feature for intersections. You can see that a lot more collisions happen at the state intersections with state signal type, and state signals are just kind of the ones that's around the on and off ramp of highways, and the city is kind of your standard 3 light. So you can see that it happens a lot more, and there is actually not that much signals at intersections for pedestrians. So like Isaac mentioned before, that is definitely an area that policymakers can look into in incorporating a lot more of these safety measures for pedestrians, since we know that pedestrian collisions definitely are a lot more severe. And I will pass it back to Faley.
All right, thank you, Cindy. And so here we just have a few suggestions for how to make this easier, and this might be applicable to data collection in general for policy. So the data is it's a blessing to have this much data available and to work with and have an analysis on this scale. But something that comes along with having so much data, and it gets messy to work with, and so having a consistent protocol for reporters would be one way to make it a little bit easier, because different groups are involved with reporting on this data. So having something consistent for reporting would make this easier to look at comparing one feature to another. And there's a lot of holes in the data when you want to compare apples to oranges, for instance. So, and that one way to help with that could be storing in a more cohesive relational database with a schema that encourages that data entry. But beyond that, in terms of studies that could take up where we have left off here with some hypotheses, like the other group mentioned, and we started to explore this as well, working with the severity metric, but having something on a city level that encouraged a consistent measurement for different, a sort of protocol that could encourage a consistent measurement for severity. That also takes into account traffic volume, which has a big impact on being able to compare one street to another. It makes it difficult to really get a good metric when you might have higher collisions on roads with higher traffic, but you want to look at roads with less traffic that also have features that are causing more damages than there should be. And a couple ideas for hypothesis testing that we could take away here is looking between similar roads, comparing the effectiveness of infrastructure that might be present on a similar road to another road. We could look at road feature differences in more detail between areas and in the city. We can look before and after specific policy changes have been made, and we can compare trends between different cities on a larger scale. And so that's all for our presentation. Apologies, it looks like we went over a little bit, so we can just go ahead and move on. Thank you all.
Thank you, team number 2. This is really great. Any questions for the team? I did have some questions. Why do you think the collisions occur more frequently in the blocks?
So one thing we noticed is that in the data set, there are just a lot more blocks than intersections in general.
So it's kind of like just because there's more area in the blocks than in the intersections, and that's why it is more likely. Was that it?
Yes, I would say so.
Okay. And my other question.
Follow-up question for.
Go ahead.
Thank you so much, teams and organizer. That's really great. My question is just follow up for Erica's question. Did you do any standardization that just normalization that just think the ratio of number of collisions over number of blocks or number of intersections?
Yes, we did look at that. If anyone else wants to jump in on that, feel free. But we wanted to use traffic flow, which had the large volume, as a way to standardize. But that was difficult because there's a lot of spottiness, a lot of areas that weren't covered, or feature types that weren't covered. And so what we ended up doing was also creating a severity metric that just took into account sheer collision. Let's see, just using collisions per month and comparing between similar types of roads, and recognizing that the collisions are going to be higher, the rates are going to be higher on more traffic heavy roads, but we didn't have the complete data to normalize for traffic volume like we wanted to.
Thank you.
There is another question in the chat that says, how did you account for the unbalanced data set features in training or when training your models?
As the blocks versus intersection, how that's in balance?
I'm not sure, but I remember that the data set was sort of, I'm not sure. Erin, do you want to clarify?
Yeah, on a couple levels. First, we know the vast majority of these incidents aren't serious collisions, right? A very small fraction of the total resulted in fatalities or serious bodily harm. And so if you're trying to predict how serious a collision is, how did you account for that when you were training your model? And then also, very much like you said, the individual labels within your features are severely imbalanced, in that case, block versus intersection. So how did you account for that so that your model just didn't predict the features that you had the most of?
Yeah, so basically that's why we kind of did the separate blocks versus intersection feature importance. So basically what we did was we split them up instead of having them all be lumped together. We did several other splits too, and then also like with the pedestrian cyclists, we did the feature importance on that, and then also the one without pedestrians and cyclists. So basically to account for that, we kind of just look at them separately.
Thank you, Cindy. Did that answer your question, Erin?
It's one approach, definitely. Jenny pointed out the imbalance in inattentive and drunk driving. Did you guys look at those?
We noticed it, but we didn't really take it out because like Philly mentioned at the beginning, we did a little different approach. We kind of we just wanted to see kind of like what is related to what basically, instead of aiming for a very accurate prediction, because we do feel like there's a lot of other features not included in the data set, like Isaac said, the lane width and how many lanes are in there. So we basically switched it up a little bit and kind of basically just tried to get insights from the model instead of trying to get like a super accurate prediction of something.
Okay.
Awesome. Any other question?
I have a question. What are the model evolution techniques that you use for this model?
Can you repeat that question?
Sure. I was wondering about what are the model evolution techniques that you guys have used to evaluate this model.
So you're asking how did they evaluate the model?
Right, you know, RMS error, or I forget the exact name of that method, but there are different kind of methods based on what kind of data and model you want to evaluate. So I'm just wondering, like, how do you guys do it?
Right. Yeah. For even though we had different targets for kind of our different modeling approaches, we were using root mean squared error to look at error metrics, which were pretty all over the place. Because again, we kind of weren't expecting to go for accuracy. And then we cross full validated 5 splits for the most part to look at feature importances on each split, and those were pretty stable. So that is kind of why we felt comfortable presenting the feature importances here.
Awesome. Thank you, team number 1. Luna, you wanted to talk about your project, right?
Sure. Just let everybody know, our group, we didn't finish our project. Should I share my screen?
Go ahead.
Okay. We didn't finish our project, but however, I still want to be here and just maybe talk about all the progress we made, and more importantly, I'm really here to ask for suggestions and help how to improve this project, because I'm committed to continue working on this and until I guess like more happier with the model. And I'm really appreciate that the visualization and machine learning group won their presentation, because by just sitting through their presentation, I think I get more idea about what I can add to potentially improve this model. So I don't have a PowerPoint. I just wrote like some talking points, and I'm just going to talk through them. So very similarly, I also thinking about how to come up with like a machine learning model so we can classify the severity label. So I started with let's just do a decision forest base model. So I just did some basic cleaning. I know since we have lots of like categorical variable, I encoded them, use one hot encoder. So I generated one column for each type, for each type of for each value of each column. And if we have like unknown as one value for for a column, I will label it as a new category. So first time when I ran the model, it's like 99%. I was like, what is going on? So the job is done. So the job is not done because we have some features that's the number of people injured, the number of car, the number of car like injured, damaged. So I think that's like linearly related with the severity code. So of course you're going to get like 99% because you really need to take them out to make the model meaningful. So good. First step, taking those numbers out, and I run my model again, and yes, it looks much worse, and now we're really talking. So this is like the baseline number I have, like from top to bottom. It's like the precision scores, recall scores, accuracy, and F1 scores. So we start from here. So I'm like keep working on like the random forest model. So what I did is I just changed some parameter randomly, arbitrarily, and seems like it improved maybe just tiny bit. And what I also did is I realized that for some binary features, I accidentally create 2 columns, and that's really unnecessary. So I removed these. It seems improved like tiny little bit, but I guess it's heading the right direction. So this is another feature I generated. So I noticed that each observation represents like 1 accident, and apparently some place is more dangerous than other place. There are there are lots of more accidents happened in the same location over the years. So I just calculated the number of accidents happened in that location and then make into a new variable, and seems like it is helping. So that's good. So I also want to mention 2 things I did that is not helping. So we both know, like for the severity code column, it has different categories, but it also have like an unknown label. So I feel like the unknown label is really not helping at all. And even if we can predict it really well, it's just not telling you anything. And for accident that is being labeled unknown, there are lots of unknowns. So I think that's why it's being labeled unknown. So I just threw it out entirely, and that's definitely like damaged my result. But I feel like that's something I should do, because having it there really doesn't help explaining the model later on. And I was thinking maybe I should try to throw away like time column, because I feel like adding more noise rather than being helpful, but clearly it's actually having it worse, so I added it back. So I was thinking, so I dive into the data a little bit, make some visualization, and I feel like it's really difficult to tell apart the severity level of incident, especially when those incidents happen at the same place. So you basically everything about that street is the same. So what could cause one accident more severe than the other one? So I feel like maybe in this data set, there's something that not being captured. For example, what type of car, and for the person, like the age of the person, their health condition, because maybe some people, they just severely injured because they're healthier, they were able to survive the accident. But I feel like those data are something like we're never going to get. So maybe this model is doomed, is never going to be really good. I'm a little bit pessimistic at this point, but so carry on. So I was thinking, okay, how about let's just try a bunch of different model and see how they do. So I just basically throw in different model here, like decision tree, naive Bayes, SGD, logistic. I just run all of them, like the basic one. I definitely see there's some good things here, in the random forest, how I'm never able to predict like this more severe event because there are so few of them. For like tree, for the decision tree, it could give me a result. So that's that. So I decided, how about I use like a vote classifier and see what this takes me. Where this takes me. So this is like the best result I have gotten. Improved, tiny little bit, but at least it's able to give me a prediction for the most fatal event. And I feel like if I'm continue doing it, this is probably where I go, trying different like ensemble method, seeing what kind of result it can give to me. So I have some questions, and I'm hoping maybe people can help me figure it out. So first question is, what do you think, like, that be some new feature that I can try to just really tell apart the severity level of accidents, even if they happen at the same place? So another thing is this is being mentioned already, like the imbalance, particularly the imbalance of this severity code feature. I have been Googling about this. There are lots of information online, but if you have something you could share, that would be really appreciate. So I think the last thing is about like using like ensemble, some sort of ensemble classifier, like voting classifier. What's your suggestion on that? And since I'm using some other method, what will be your, I guess, like suggestion on improving them in terms of changing parameters? And I guess last thing is for people who currently working as like data scientist, machine learning engineer, like for your job, for example, if you being asked to do a model, like what would be like a pass result? Like if you get accuracy score at certain level, like certain threshold, then this model is like basically working. Do we have like some sort of like industry standard for that? I'm really curious. Yeah, so that's it. Thank you very much, and really appreciate your help.
Thank you, Luna. Anybody has recommendations here for Luna? Can you put up the questions so that we can remember?
I don't remember all the questions, but a couple of tips. Just, I'm not sure if you have done statistical tests to see if the features are statistically significant regarding being relevant and to what you are trying to predict. If there is any signal there, then that's the good news. If there is no signal there, then as you mentioned, actually it was interesting insight that maybe data set is not capturing what you need. But that's one more thing that maybe you could do. Another thing is that I remember that the team who worked on visualization worked on the metrics, defining metrics, specifically defining the severity. Maybe a little collaboration and help from them would help. Will help too, to see what they got.
Thank you.
By the way, good to see you around, Luna.
Sorry, I couldn't hear you.
Oh, she said that it's good to see you around.
Oh, thanks.
Erin also made some suggestions in the chat for dealing with imbalanced data. So I would say for imbalanced data, in my experience, maybe tree-based models are the best, especially ensembling techniques like gradient boosting, because they really focus. So gradient boosting, as you might know, they really focus on what went wrong in the previous prediction, and then try to kind of optimize for the next. The next tree tries to compensate for the errors that the previous tree made. The downside of this is that you might end up overfitting your model, but in this case, I'm not sure, maybe you need to do something like that. Yeah, so tree-based models are good for that. If you want to be more sophisticated, you might also try to change the loss function or like the error metric of your models and kind of weigh more the errors that are done on the represented class. That is like a classic technique that can be worked for any method, but that's more difficult because you have to customize your losses and your error.
Yeah.
So, yeah.
So I have a question. So I was trying to do a grade search. It's just way too long to run it. So I was wondering what would be like a good starting point.
Oh, hyperparameter optimization is a whole other topic. Instead of using grid search, instead of using grid search, you can use like a base or Bayesian-based hyperparameter optimizer. That is something that is also done. It's kind of like a more informed search in the hyperparameter space that you can have. You can have ranges, but it won't be like totally random, that you will have to try very different, like a lot of different combinations to train that. But you can try something similar.
I also wonder, does anyone like have experience like with the industry can maybe give me a little bit insight? Like, for example, at work, you are responsible for training the model. What would be like considered like a passing like model in terms of like prediction?
Yeah, I also wanted to address that, and that is a very good question. And I don't think it's like a straight clear cut that you say everything above 85% will be acceptable.
Okay.
That unfortunately, I think in data science and everything related to data, it depends on the data, it depends on the problem, and it depends on the on the metrics. It's not only accuracy, but sometimes you want to optimize for something else. You're willing to trade off, let's say, correct predictions in order to reduce the number of false positives. Let's say you have, the classic example is like, if you want to, let's say, predict who's gonna be sick, that's something that you don't want to. You either don't want to miss any possible people that is sick, or you don't want to scare people, like without a reason, right? Because your model make a mistake, and then you inform the person that is sick, then the person gets scared, and you don't want to do that. Or the other side of the coin is, oh, I don't care if I scare people as long as I can get all of the people that are sick, even if that increases the people testing positive by 50%. So that really depends on your use case, and
Thank you.
I would say I would add to that sometimes even stakeholders don't know what they want, so it's up to you to kind of research all of the trade-offs and give your recommendation. So in this case, and maybe this is a question for all of the people that were involved in the project. What would you prefer? Would you prefer to be more precise by predicting severity, or would you be more relaxed and say, it's fine, I just want to be more, I don't know, more certain that I will catch all of the severities that are really high? I don't know if that makes sense. But yeah, that's something that you can actually do, and sometimes you have to, in my experience. But I know some other people here work on that. Maybe Magnus, you have another insight here?
I don't have that much to add to what you said. The answer is it depends. And the only thing I'm not sure if you mentioned or not is sometimes to move, play with thresholds, and just when you are defining your metrics, and just to see how severe is it, I mean, how much severe is severe, or how much, just definitions. That's one thing. Even in the model predictions, when you build your model, for example, adjust the thresholds again to assign the cases to one category or the other one, and it doesn't have to be 0.5, for example, for a case to be severe or not. Maybe if the maybe we should put the threshold 0.7, 0.8 even, just to make sure that when we say it's severe, it is severe. Yeah, other than that, one last thing that I was thinking about, because the data set is big, I don't know, I didn't play with the data set, I haven't seen it, but if the database is, the data set is big enough and you have enough of data, maybe you can unskew the data set by just randomly sampling from negative samples, probably as much as twice as positive samples. That would be something I would try if I have enough data. The data won't be skewed.
Thank you. That's really helpful.
All right, thank you, Lola. Anything else?